As Raul said, I'm Martina Rauert. Nice to meet you all. And I'm here today to talk about test-driven development. Woohoo! All right, so I already got a fan. Love it. So when I say test-driven development, who here thinks they know what that means? Raise your hand. Okay, so most of you. All right, that's good. Keep your hands up. Now, out of all of you, who would say you've done it before? Maybe just once, maybe just for an assignment. Okay, you know what? That's pretty good. I'm happy about that. Okay, so now out of all of you, who here would say they do it all the time, every feature they do, make their best effort, whatever, Brennan, put your hand down. Best you can do every time you're test-driven developing something. We got one, yay, brownie points for you. Okay, so point is, we all know what test-driven development is, but no one's doing it. So I'm not here to really teach you what test-driven development is, but I do hope to help you realize the benefits of TDD and what it can provide to you and your software development process. All right, so just a quick agenda. Just to warm up your brains, we're gonna start off with what is test-driven development. Then we're gonna go over the benefits that I think are test-driven development. Then I'm also gonna go over programming by coincidence versus deliberately. This is not a term I've come up with, but I think it very perfectly articulates why I think TDD can be so valuable. Then we're going to get into a practical example. So we're going to start with the basic steps of how you might approach doing TDD. I'm going to show you an example, and yeah, then we're going to have a conclusion. And you'll all be doing TDD by the end of this, I hope. But first, an anecdote. So I know most of you don't know me, but one of my biggest hobbies and passions is to do art. So obviously in school, I took all the art classes I could every single year. I was always in art class. So I had this one art teacher from grade 7 to 9, I think, and his name was Mr. Ackland. And he was like this big, ferocious, brute of a Scottish man. You could think of him as Groundskeeper Willie, with his bald head and sideburns to boot. But with a much more PG level of ferality, because he obviously was teaching junior high school students, and with a paintbrush in his hand. So that's Mr. Ackland. But in all seriousness, I actually learned a lot from Mr. Ackland. He was a great teacher, and one lesson that always stuck with me that he taught me was measure twice and draw once. So this basically means if you need to draw a straight line or do anything precise, it's best to measure twice in some way before you draw your line. You're much more likely to get it right the first time if you have like 2 checks to go off of from the start, instead of having to go back and fix it. So if you measure once, you're probably gonna end up drawing twice. So just as a quick example, drawing a line requirements, we're gonna define some. We're gonna have a piece of paper, 12 by 12, doesn't matter. We wanna draw a line from 4 inches from the top, and it needs to be parallel to the top of the page. Okay, so what's the first step? We're gonna draw 4 inches from the top. We have a ruler, by the way. You can assume we have a ruler. So we can measure 4 inches from the top, and this can be implementing that requirement. And that's all fine and good. And maybe now we take our ruler, attempt to draw our line, and maybe by coincidence, it ends up perfectly straight, and it's parallel to the top of the page. And that's great. I mean, can't fault for doing it right. But you're much more likely to maybe end up with a line like this or like that, because it's a lot harder to draw a straight line if you don't have another point to go off of. So instead, if our first measurement is like a test of our requirement, and we can do a second measure from the top of 4 inches from the top, is then implementing that requirement, we're much more likely to get our correct line the first time. So that's measuring twice, drawing once, getting the right line the first time. So I know this is not like a new concept. Probably you're all more familiar with measure twice, cut once, which obviously if like a 2 by 4, you have to cut it to a certain size. You probably want to measure twice, because if you cut it up, you do it wrong, you might end up having to go to the hardware store or whatever and get a new piece of wood because you screwed it up the first time. So this idea is not exclusive to drawing or carpentry or anything. It doesn't matter the application. Measuring for your requirements more than once has a higher chance of success. That's the whole point. So it means you're doing that extra check, maybe a little extra work up front, but it means it will prevent you from having to go back and redo your work in the future. So I'm going to come back to this. Hopefully by the end of this talk, this will all become clear. But yeah, this is kind of That's my anecdote. So what is test-driven development? Also, I'm going to say TDD a lot, so get used to me saying that. That means test-driven development. Means your requirements are turned into test cases. So I bet you all thought I was going to put first, you write your tests first before you write your code. But no, I think the better way to approach it is your requirements are turned into test cases. You have to deliberately understand what your requirements are, what your inputs should be, and what not only just what the output should be, but how and why you're going to get there. So the requirements are key to TDD. Then yeah, of course, then you write your tests first before you write your code. I mean, you turn those requirements into tests. Once you have those requirements, it comes naturally, you can make those tests. And tests should be a continuous part of your development process. So it's not just writing them all first, and it certainly shouldn't be writing them all after you've written all your code. But testing should really be a continuous part of your development process. If you need to add a new application service or a domain object, you should be thinking about those requirements for that piece of software and writing tests based around that. Okay, so that's TDD. And some of the benefits of test-driven development are, of course, ensures you understand the requirements first. Not only that you understand them, but you know you have them all. You can't really start writing software if you don't have all the requirements. And continuous testing also ensures fast feedback and helps find errors and problems early. So if you wait till the end to write all your tests and suddenly they're all failing, you may not really understand why that's happening. So if you write tests as soon as you're adding code, or sorry, before you add a new piece of code, you're going to get that really fast feedback immediately and know what's going wrong very quickly. It also forces your code to be testable and maintainable, which is obviously very nice. It's very good. All code should be testable. Oh, sorry, thought you had a question. All good. So it can, if you wait up to write all your tests at the end, of course, it can be easy to fall into a trap of, well, by coincidence, all the surrounding code around this maybe untestable application service or domain object, maybe everything by coincidence has worked so far, and you're kind of, you think you're confident that the intermediate class is okay, but you can't test it, so you don't. Then something changes or someone enters input you weren't expecting. You don't really know why it broke, but it did. But now you can't test it. So that's, no developer wants that. All your code should be testable, and this forces you to do that. Refactoring's a breeze. I mean, as soon as your tests pass on a piece of code, you can change it most any way you want, and as long as the test passed, you know you didn't break anything. So you really have that confidence there. And most importantly, ensures you write tests that are correct and not just confirming that your code works. So writing tests after you write your code, like yeah, maybe it tests something, you're testing your code did something, but that doesn't mean that's correct based on your requirements. And that segues into, it's a method to ensure that you are programming deliberately. So that is going to segue into my next section here, which is programming by coincidence, which is what I hope we should all avoid as developers. So what is programming by coincidence? So suppose you keep writing a program and it's all working fine and good for a while and it serves your purposes and that's all fine. And then one day it breaks, and despite looking at it for a while and spending a lot of time and effort, you won't be able to fix it. And the reason why is actually pretty simple. You never knew why it didn't work in the first place. So programming by coincidence means you never knew what you were doing in the first place. Your code has, up until this point, relied on luck and accidental success. And you should avoid programming by coincidence at all costs and start programming deliberately. So what does, oh no, my points didn't come in. Okay, whatever. So what does testing have to do with it? Why am I even mentioning this? So if you're writing tests after you write all your code, you're probably programming by coincidence. If you're letting your code dictate the answers to your tests, you're not really testing anything at all. You're not demonstrating that you actually understand what's happening. If you believe your code works and you write your tests that pass on that code, you're just confirming what's already happening. And these tests confirm your code does something, whatever that is, but it doesn't confirm that it's actually correct. So we should all avoid that no matter what. Even if you don't TDD, avoid this, please. Okay, so what's the alternative? It's programming deliberately. So programming deliberately means you always are aware of what you're doing. You don't rely that things work. you always verify that you know why and how they work. And to kind of throw back to Alex's talk, if you don't know how it works, like code is harder to read than it is to write. If you don't know how it works when you read it, how is anyone else supposed to, right? And also, you understand your requirements before writing any tests or code. So again, that's understanding what your inputs are and not just what the output is, but all the how and why in between. So what does this have to do with testing? Why am I bringing this up again? So it forces you to understand the requirements first. That's what test-driven development does. You don't just believe the test and the code works, you know why it does, because you understand those requirements so well. And your tests no longer confirm your code simply does something. They are now confirming that your code is correct. So programming deliberately is an approach to programming we should all be practicing, and test-driven development is a tool that we can all use to help us do that all the time. Okay, so now on to a more practical example and approach to this. So basic steps of test-driven development. Just to really drive this point home, the first step should be to strictly define and understand those requirements. And then once you do that, you can turn those requirements into test cases. And then you should run the tests. I know it seems like redundant, or not redundant, but menial at this point, because they're going to fail. They should fail. But there is a few important reasons to do this. It ensures your test hanger is set up properly. And also at this point, if all your tests pass, you know you did something wrong. Like, you know your tests are bogus. You should go back and look at them and make sure that they're actually matching your requirements and are correct. So you've done that. So now at this point, you can finally write some code. And honestly, at this point, writing the code should be the easy part. You already figured out what your requirements are, and you've written tests to prove that. So now you understand it so well, writing code should be the easy part. And now, of course, you can run them again, and you want them to pass, but if they don't pass, this is what you don't do. For the love of God, do not do this. Do not let your code dictate the results of your tests. That is programming by coincidence, by far. What you should do is go back to step 2. So that's all the way back up to looking at your tests. So at this point, you should be thinking about, okay, what's wrong with my tests? Do they match the requirements? What have I done wrong here? And then, well, if they do pass, then you can continue to the next step, which is you can then refactor. Your tests are passing. You know your code is correct. So now you can go and refactor with confidence, and that is a glorious thing. And repeat as necessary. Any new features you need to add, or any new, even application service, business logic, whatever. You can follow the same process for any new requirement that comes in. Okay, so now we're on to an example. So let's define a feature via a user story. So as a user, I can use the form to enter 2 numbers. When I hit the submit button, it displays the result of applying the algorithm of those 2 numbers. So what's the algorithm? We gotta define these requirements a little better. So what are some better requirements here? So there's a form, 2 text inputs, taken numbers, and a submit button. That we already kind of knew. When they hit submit, the following algorithm is applied to those numbers. So now we're getting some more strictly defined requirements. If the second number is smaller than the first, add them together. If it's larger, subtract them. So pretty menial and boring, but that's our algorithm. Display the output to the screen. That also we already knew, but now we got something to work on here. So now we're not done with requirements. As a developer, we can actually define some technical requirements. One of them being, we're going to render the form using React, so we're really deep diving into the technical details here. When they hit the button, apply the algorithm, display the result. That we already knew as well. But as a developer, we can decide that we're going to create a helper util to do the calculation on the 2 input numbers. So as a developer, we probably don't want to be doing any kind of algorithm or calculation in our UI component or anything like that. That should probably be offloaded to something else. As menial as this algorithm is, we don't want any of that logic in our UI. So even though this wasn't a requirement of our user story, as a developer, we've made this requirement. So now this is something we should look at, consider, and write tests for. So I have, how do I do this? So I just recorded a video of me doing this. I think it's actually not at the start, which is not great. No, it is. Okay, so here's our app. We've already added just a little entry point to it. Hello world, very clever. So it's an app, and I'm gonna start running my tests because that's set up. And I've already written a test because that's the way I am, and it's going to pass. And another cool tool you could do is actually have your tests run whenever you save your files, and that really helps with your continuous integration in TD and all that. Okay, so now we're going to actually add our util, as I specified on the previous slide. Just going to call it algorithm.js, which is a great name. But first, though, we should add our tests for the algorithm. All right, so here we go. So now our tests are failing because there's nothing in algorithm test.js, which is great. We want that to happen. So I'm going to go ahead and import a function that does not exist from my algorithm file, and that's totally fine. We're going to define it later. And so describe algorithm. Oh, spelled it wrong. Not shocking. I'm a terrible typer. All right, so I didn't realize I screwed up so much. Okay, so they still fail. That's all great. So now we can define our test cases based on our requirements. So the first one is the addition requirement. Takes the two inputs and adds them together since the second one is bigger. That's all fine. We're just going to leave it as a stub for now. So then we're going to copy that and add our second test case and subtracts them. So this just passes because now it's not complaining. We don't have any tests in here, but we all know that this isn't a valid test yet. So let's start writing our tests. So our input 1 is 5, input 2 is 10. And we're going to think for a minute. And now we're going to expect our call to our function, input 1, input 2. It's going to be the addition of these two numbers. So we can all do math. If you have to pull out your calculator, that's fine. But it's going to be 15. So now we're double checking. Input 2 is larger than the input 1, so we know it's going to be 15. Okay, so it fails. You know what? We're expecting that. That's totally fine. So now we're going to do our second test where input 2 is less than input 1. So now we know it's going to be a subtraction operation. And once again, if you have to pull your calculator, that's fine. We know it's going to be 5. Okay, so they're both failing. That's fine. We're okay with that. So now we know we can go back and write some code. So now we're going to export our function here. Add sub, also very adequately named. Takes our two inputs. And it's going to return 0 for now just to see what happens. Okay, so now our tests are failing. Of course, because we're expecting 15 and 5 and we just returned 0. That's great. We're happy with that for now. So to address the first use case of the addition of the numbers, we're going to make that if statement there and return the addition of the two inputs. We think it's going to pass. Oh, right. I forgot I made that typo. So it should be passing now, but it's not. It still thinks it's 0. We look at our second test. Oh, we know. Okay, so it's hitting our second test is the one that's hitting that conditional in there. So let's go back to our test. Check our input. Okay, input number 2 is 10. We're passing it as a second parameter. So we know this test is correct. Based on our requirements, the second input is larger. So what do we do next? We go back to our code. So what's wrong with our code? Our logical operator is wrong. So we go back and fix it. Oh, our test is passing. That's great. All right, so now on to our second use case. And we're going to do our subtraction use case. And keep typing a little faster there, Martina. All right, so now this test also fails. So go back to our test. Take a look. All right, so our second input is 5, which is smaller than input 1. We're passing it as a second parameter. We're confident here, again, our test is correct. So let's go back to our code. What did we do wrong this time, for crying out loud? Okay, so we subtracted the wrong number from the wrong number. And now they pass. But what have we discovered along the way? What do we do when they're equal? So this is a requirement that we haven't defined. We need to figure out what to do in this case. So I'm going to still add a test for this, because we need to figure this out. This is a to-do item. You should put on your, I don't know, Scrum board somewhere. And run it, and it's going to fail. And that's the way you should leave it, so you know that you need to go back and and figure out what that requirement should be and then fix the code to match that requirement. Okay, so how do I get out of this? All right, I lost my cursor. Where did it go? Okay, I found it. All right, so, back to the anecdote. So hopefully now it's become clear that we're doing double checks on everything using our TDD. So back to our drawing our line. So we have our page, 12 by 12 piece of paper. Must be 4 inches from the top. So if we're not doing TDD, writing code and then writing tests, that's just like our one check on our requirements, that one measurement. So by coincidence, you know, we might end up with the right program. It might work for a while. I might be pretty happy with that. But just like I said before, you're just as likely to do it wrong and not know why, and it's behaving unexpectedly and you can't understand how to go back and fix it. So instead, if our first measurement from the top of the paper is us test-driven developing our requirements, our second check is actually implementing those requirements by writing code, of course. We're much more likely the first time to be able to draw that straight line the first time and get the correct program. So, in conclusion, requirements come first and your test cases will follow. And test-driven development is not just about writing tests first, but incorporating tests as a continuous part of your development process. It ensures your code is correct and not that it just does something. It's an invaluable tool to program deliberately and avoid programming by coincidence. And for the love of God, do not just write your tests last and copy and paste the result your code spits out. And that's it. So yeah, I was highly influenced by the Pragmatic Programmer, so if you haven't read it recently, I highly recommend that. That GitHub repo is public if you want to take a look at that example that I showed. It's not that interesting, but feel free, it's fine. And if you have any questions, let me know. And that's about it, so thank you very much.